Right, let's do question 1. We're going to start by doing question 1A1. It says solve for x and it's for 2 marks. It is very important that you check the mark allocation. Since it is 2 marks, it means that we don't have to do a lot of calculations. Right, if you check this is already factorized for us. It's now in the form a times b is equal to 0. See that? So it means we have our two factors that if we multiply them, we get 0. So it's either x divided by 4 minus 1 is equal to 0, or x plus 2 is equal to 0. Please don't be tempted to expand this. There's no need to expand. Maybe if it was like this, maybe x minus 1 like this, and then x plus 2, and then equal to, say, 1. Then you'll have to expand and get the standard form, and then continue from there. But it will be more than 2 marks. Mark allocation will guide you, right? So what we do here, x over 4 is equal to 1. Then we multiply by 4 on both sides of the equation. X is equal to 4. Or x is equal to negative 2. Then you get your 2 marks. That is question 1A1. Right, let's do question 1A2. Use the formula. We are given the quadratic formula here to solve for x. If 2x squared minus x is equal to 12, and then you have to show all your calculations. What we do, we have to write this in standard form. So it becomes 2x squared minus x minus 12 is equal to 0. Okay, and then we have our a is equal to 2, b is equal to negative 1, and then c is equal to negative 12. And then we substitute into our formula. X is equal to minus negative 1, and then plus or minus the square root of negative 1 squared, and then minus 4, and then what is our a? 2, and then what is our c? Negative 12, like that. And then all this divided by 2 times our a, which is 2. Okay, we can put this in the calculator straight away. We don't need to do anything else. Just put this whole thing in the calculator. You can start by putting plus, get your answer, then go back, remove plus and put minus, then you get your answer. So it becomes x is equal to 2,71221445 before rounding off, or x is equal to negative 2,21221445, like that. And then we have x is equal to 2,71 to 2 decimal places, or x is equal to negative 2,21, like that. These are the values of x. Okay, let's do question 1A3. 1A3 is an inequality. Right, we solve an inequality like we're solving an equation, but the only difference will be in the solution. Please don't leave your answer as that of an equation. This is not an equation, it's an inequality. So all the way up to the critical values, we are solving like we are solving equations. So here what we do, we have a highest common factor here, which is x. So factor out x, and then get x plus 2 is less than or equal to 0. Right? So meaning that our critical values will be x is equal to 0 or x is equal to negative 2. Right? How then do we find our solutions? There are many ways of doing this. I'll show you the first one, which is the number line. Draw the number line like this, and then we have the smaller critical value, which is negative 2, put it there, and then the bigger one is 0, put it there. From 0 to the right, that is x greater than or equal to 0. Then from negative 2 to the left, that is x less than or equal to negative 2. And then between negative 2 and 0, that's an interval. It means x is greater than or equal to negative 2, but less than or equal to 0. That's an interval. Then choose any value that is less than negative 2. Let's choose negative 3. All right. If you put negative 3 into this, what we get? We have x squared plus 2x. Let's put negative 3 there. It's negative 3 squared plus 2 times negative 3. And then what do we get? This is 9 minus 6, which is positive. 9 minus 6 is 3, so it's positive. Remember, less than or equal to 0 means that the value of this function should be 0 or negative. Less than 0 means negative. Greater than 0 means positive, right? So it means this one, when x is less than -2, this function is positive. It's above the x-axis, so it's out. We want where it is going to be 0 or less. Let's put a number between -2 and 0. Let's say -1. If we put -1 into this function, become -1 squared plus 2 times -1 like this. -1 squared is 1. 1 plus -2, that is 1 minus 2, which is negative. So this is negative. That's what we want because it says less than or equal to 0. So it means it is in this interval where this function is below the x-axis, or where this function is negative. All right, let's just test this one. Let's pick any value greater than 0. Let's say 1. Put 1 into this function, then becomes 1 squared plus 2 times 1. Then obviously we're getting a positive answer there, which is 3. So this is positive. Positive means greater than 0. So this one is out. So the solution is what? Is x greater than or equal to -2, but less than 0. That's your solution. Right, there's another way of using the graphs, right? You know that this is a parabola. This is a parabola. So it's concave up. So it's going to be like this. And then the critical values, these are your x-intercepts, right? X-intercept is at -2 and at 0. And then we're saying, where is the graph less than or equal to 0? Where is the graph below the x-axis? Remember, I said this is what? This is the x-axis. So where is the graph below the x-axis? Is here, between -2 and 0. So we're saying x is greater than or equal to -2, but less than 0. That's an interval. Okay, so that's the solution there. Or just know that once you have less than or equal to 0 like this, you are going to have your x here, which is greater than or equal to, because there's greater than or equal to there, greater than or equal to the smaller critical value, but less than or equal to the bigger critical value. Okay, remember that. And then if it was greater than or equal to 0, then you're going to say x is less than the smaller critical value, or x greater than the bigger critical value. Remember that. Okay, so you can use the number line, you can use the graph, you can remember this. Okay, all right, let's do B. Determine the values of k for which the roots of this function are equal. So here we have to use the discriminant. Discriminant, the delta there. This is the discriminant, right? We know that if the discriminant is equal to 0, then our roots are real and equal. That's what we're looking for. But just to discuss, if the discriminant is greater than 0, it means the roots are real and unequal. They are real and unequal. And then if the discriminant is less than 0, it means the roots are non-real. Okay, and then remember, if the discriminant is a perfect square, then your roots are rational. So remember those 4 points. So here we have to write this in standard form in terms of x. So you have to have x squared x, and then anything that does not have x is your constant. That's your c. Okay, so we're going to distribute x here. Becomes half x squared plus 2x. Then let's bring this k to the left hand side, plus k squared is equal to 0. So meaning that our a is equal to 1 over 2, our b is equal to 2, and our c is equal to k squared. Right, let's put it in the discriminant. Remember, the discriminant is b squared minus 4ac. So where there's b, you put 2, becomes 2 squared, and then minus 4, and then a is 1 over 2, and then our c is k squared, right? This should be equal to 0 because we say the roots are equal, so it's equal to 0. Then becomes 4 minus 2k squared is equal to 0. Then 2k squared is equal to 4. Then k squared is equal to 2, right? Then we square root both sides, becomes k is equal to positive or negative square root of 2, like that. These are the values of k.